Hello there, and thank you so much for joining me here at my talk at ContainerDays 2022. I'm really excited to give this presentation called Integrating Cloud-Native Security into the SRE Culture. Now, my name is Anais Urlichs. I'm the Open Source Developer Advocate at Aqua Security. A little bit about my background and why I'm passionate about talking how to integrate security into site reliability engineering and into the culture that goes within. Well, I was working last year as site reliability engineer. Before that, I was working as developer advocate. Now, given that I just joined Aqua at the beginning of the year and I started to focus more on security tooling and working with our open source security tooling, I found a lot of overlap between the tools that you're using within site reliability engineering and the tools that you're using and how you actually access the information from your security scanning. So, just to set the scene, this is a slide that was within a presentation that my manager at the time, Alex Jones, and I gave last year at KubeCon North America. We were basically talking about how the startup that we're working for was using Kubernetes clusters to spin up tenant clusters. So this is basically the visualization of a compute rack that we had in one of our compute regions. So for example, imagine a compute rack that's standing in Frankfurt or in London or in New York. And within it, there are several compute nodes. Now, this is kind of a view of a supercluster that we had. So we had running across this compute stack a cluster, and that was the supercluster. And whenever a customer would spin up a tenant cluster, it would be scheduled on any of the compute nodes within that is free. So we had basically clusters within clusters. Now, as you can see, this is a really large scale environment where lots of different components are moving, are changing around. And you have to really keep track of the observability of your different services to understand whenever a component within a supercluster is down, or whenever a tenant cluster is not working like expected, you actually can track back of what happened, what are the logs showing, what are the other metrics that you're observing, showing that help you analyze what went wrong and help you fix that, right? It's a vast moving environment. And here are some of the tools that we were using at the time. We were using heavily Grafana, Prometheus, we were using Loki, some Jaeger tracing, we were experimenting around with that. Also with Thanos, since we had several major clusters, several super clusters, we didn't want to implement Prometheus as a standalone in each of those clusters, regions, but actually have a global view of it all. And then for management, for deployment, we used Terraform and Helm a lot of the time. And then for Git and deployment, we used GitLab and their CI/CD pipelines. Now, the thing is here, where is the security tooling, right? We don't see any security-focused tools within here. And actually, there weren't any. And I'm going to talk in a second about why that was. So, first of all, to provide more context about site reliability engineering, about the culture that I'm referencing, what is it actually? Well, part of it is analyzing and learning from failure. So whenever something is wrong, you want to be in a position where you can analyze what went wrong and you can respond to that. And that's highly correlated to continuous improvement, right? You respond to the data that you receive and you can improve with the data. So it's basically making informed decisions about any component that has to change and embracing the change and embracing the risk that comes with it, right? If you're aiming for 100% uptime and you're never experimenting around with things, or nothing ever fails, then ultimately you're also not embracing risks and you're not improving your infrastructure, most likely. Then the last thing is also autonomy. Within your SRE team, you want to embrace autonomy. You want to be able in a position where your stack, your deployment process is so robust that nobody can break it as a single individual, right? So that's something that I, for example, contributed to a lot. I tried to break our cluster and our deployment process, our infrastructure and different tools. And whenever I managed to break something, we had to improve those processes because they shouldn't ultimately break by one person making decisions by themselves that haven't been cross-checked. For example, by updating, you shouldn't be able to update random YAML manifests in your production environment, right? Now, the premise, going back to my talk, is that a lot of these processes that you have within your SRE culture are also processes that you can benefit from when you're integrating your security tools. So ultimately, SRE practices have a strong overlap with security practices. SRE goals are security goals. When we define what's a healthy service is like within our stack, within our application, we also have to define ultimately what a secure service looks like. Because ultimately a service is not healthy if it's not secure. If a customer can access your endpoints, can log into your application, but along the way their data is exposed, it's not a healthy service. That's ultimately the premise here. So when we're talking about our SRE goals, we ultimately also have to talk about our security goals. For instance, when we're talking about scaling our application, we have to define what does scaling look like security-wise. How do we keep our application secure? If you have one endpoint, it's really easy to track like any issues, any security issues, any vulnerabilities related to the components that are used within that service, right? But once you have several hundred, maybe even thousands of services, it becomes a lot more difficult to track that and to make improvements upon your security for your application. Then the next thing is visibility. We can only make informed decisions if we have visibility into what's going on within our services, within our different components, right? Like you can't improve the reliability of a service if you don't know which components might be failing. And it's similar for security. There are so many different components within your cloud native infrastructure. And it's not just a container level, it's not just the Kubernetes level, but it's really across your entire, ultimately, Linux stack, where things can go horribly wrong. And there are other presentations that I can link to that go into detail of what that actually means. But because of that, you need to have visibility into which components are going wrong or could go wrong or are more likely to go wrong, to improve them and improve the security of them and make them more robust. The other thing is that in SRE, we talk a lot about reducing noise, reducing the toil that we have to deal with on a day-to-day basis. Because ultimately, if you have so many data points that are providing you with information, it's really difficult for a human being to filter out of, hundreds of logs. So you need to have a smart logging system that helps you to filter through your logs and make an informed decision upon your logs, right? And it's similar with insecurity. A lot of times when people get started, for example, with security scanning, they are bombarded with maybe even hundreds of vulnerability issues, for example, even in their container images, and they don't know what to do with that. It's a lot of information, and it's definitely not the right way to deal with the security of your application, to look at everything at once and just try to fix everything, right? You have to filter out and try to minimize the amount of information that you receive. Next thing is automation. Automation is really, really great because we don't have time for everything in a day, and humans make lots of error. We love making errors, so it's great to automate ourselves out of the job. The thing is, when your automation goes wrong within SRE, within site reliability engineering, your system is likely programmed to scream at you until you fix it, right? If an endpoint, a service is not working, not responding to health checks, it should at some point scream at you until you fix it. That's it. As simple as that. Now, within security, we often don't program our security tooling in the same way. So it's easily the case that we can just ignore it. So if we don't feel like fixing the vulnerabilities in our application, we can just ignore it, just look away, fix it another day, right? We don't have to take care of that right now in that moment. Our application will still work, customers will still be able to access it. And that's kind of the difference that we have to keep in mind. Also, not only from an engineering perspective, but also from a management perspective, that we have to give people the space and the resources to fix those issues. Last thing, like just mentioned, ownership and communication. It's really, really important and maybe one of the most crucial components. Now, there are lots of different processes that we can benefit from also when we define how we approach security within our organizations. Here are some listed that are from site reliability engineering and that we can kind of adapt to our security implementation, security components. So the first thing is, for example, when we invest into runbooks of how do we respond to incidents, we should also define how do we respond to security vulnerabilities within our stack. Just as one example. We have to make sure that people know what they expected to do, when they expected to do it, and how they expected to do it, right? So, and that's really like benefiting from active communication within your engineering teams. So you want to define procedures and processes so people know what to do. They feel empowered to do the right thing, right? If somebody, especially like more junior engineers, don't know how to raise concerns related to security, and if they're not empowered to do it in whatever way they think is correct, then they won't raise it. They won't open their mouth. It's as simple as that. And you want people to speak up, right? So another thing is that security can get easily very, very complex. So you want to get started with security as early as possible, and not just early as possible within your within your startup company growth, but also as early as possible within your development lifecycle. So for instance, when we define our development lifecycle, when we're looking at the different things that are going on within our engineering teams, from developing the application to ultimately building our deployment manifests and then deploying our application. At each stage, we can do different types of, for example, security scanning. So when we develop the application, we can scan packages, remote Git repositories for security issues. Then when we define our infrastructure as code configuration, we can scan that for misconfigurations. We can scan base container images for misconfigurations or for security issues. We can make sure that container images that we're using have an attestation attached to it, that we know that it's from a trusted authority and it's not just from some random person, but actually that, for example, if we use Node container image, it is actually published by the Node repository, not just by some random person on the internet, right? Now, a lot of these things we can automate again. Like you might want to run some scans on local machines of each engineer, but then there's a lot of the scans that you can do on a more global level, for example, in your CI/CD pipeline. And those are ultimately, if you have a larger team, also different people who will perform those different scans, right? Not one person should be responsible for everything. Like you might want to have, if you have a security team, you might want to have them doing the more automated tasks. But ultimately, whoever is dealing with engineering resources and whatever engineering resources, doesn't matter, can perform security scans on those. And that's what you want to get to, that people know that and are empowered to do that. And it's not just shifting left and telling engineers to do yet another thing because they already have so much to do, but it's really like showing them which part they're responsible for to make the deployment happen in a successful way. And again, successful is defined by your goals within, not just within your SRE team, but within your deployment lifecycle and like the health of your application itself. Now, the last thing is that also you can do in-cluster scans of your running workloads, of your running services, of your deployed services. And this is done either by cloud scans, such as scanning your cloud account, or if you run, for example, Kubernetes cluster, you can perform scans in a Kubernetes cluster. And I'm going to show you that in a few minutes as well in the demo. So you want to focus on establishing a security-centric mindset within your engineering teams. And this is really done through shared ownership and consistent communication. That's ultimately what it boils down to. And I did another talk where I compared, which is kind of more of an introductory talk to, or like showing the state of DevSecOps and cloud-native security. And I compared cloud-native security or security within your DevOps teams to climbing. A lot of it is very similar, that you have to set your goals. You have to define a path that you want to achieve, right? That you want to follow. And then ultimately, well, some of the engineers are, for example, developing the application. So in this case, the climber here, you have other people who are there who can help out, who can point out things, who can assist with things that they might see from a different perspective, right? To ultimately advance as a team. Now, going back to tools, right? Observability tools. You can integrate security tools. And in this case, I've just put here Tracy and Trivy that are main open source tools by Aqua Security. Trivy is an all-in-one comprehensive security scanner, and Tracy is runtime security. Now, we are going to focus on Trivy in this specific example. So how do we integrate security tools? This is another big topic, right? First, you have to choose a tool. And the difference between tools really becomes visible when you have to choose a tool, and you have to kind of bear that in mind, that there are lots and lots of different security tools out there. I'm going to show that to you in a second as well. Also open source security scanners primarily. And they will vary in these different areas. In installation, some tools might be used directly in your CLI tool, like CLI terminal, or in your CI/CD pipeline. Other tools might be deployed as a Kubernetes YAML manifest or as a Helm chart. Other tools might be run as a website, right? As clicking buttons, and that's how you use that tool, and you provide it with, for example, your Git repositories or other things, other resources. Installation between different tools will widely vary, and also depending on installation, the focus of the tools will be different. So the scan coverage of what is actually the tool scanning for, what resources is it using to scan, used to scan your resources, will be different between different tools, right? Some security-focused companies have a research team behind them, such as Aqua Security or open source tools. We have a research team that is frequently deploying, on a regular basis, deploying honeypots and seeing how attackers exploit vulnerabilities within those honeypots. And then based on that, our tools will have different rules implemented from the get-go. Now, especially if you don't have security experts within your team, you want to ensure that the security tool that you're using is very comprehensive. And you can basically, you can rely on it that the scans that are performed are covering the main areas that might fail security-wise. Now, the other thing is integration. Especially when you're going for open source tools, there's nobody who will help you, nobody who is paid to help you with integrating the tool into your existing stack. For example, more mature open source tools will have different integrations developed either by the core maintainers or by the community. Now, less mature open source tools won't have those integrations available yet, or won't have the documentation yet on how to make those integrations. Then the focus of the tools is again is it focused on engineers, or is it focused on class admins? Whom is this tool focused on? And depending on that, the value that the tool brings on each stakeholder, each user, will be different. Now, other factors on how to choose a tool is the size of your team, right? Who's handling the tool? What is their experience level? Then what industry are you working in? Are you working in a really highly regulated industry or not? These will be factors, components that influence the tool that you're choosing, because ultimately, depending on that, you want to use different tools that provide different types of scan coverage or different types of resources to provide information on the scan coverage. Then the type of technologies that you're already working with, again, you want to compare the integrations that are available for an open source security scanner and compare that with the stack that you already have in place. Then company goals and leadership. Is security supported and valued from a leadership managerial perspective or not? What is the budget and the expertise available within your team, right? In said open source startup, where I was a site reliability engineer, we had an intern ultimately implementing security tooling, and it worked well, right? They were empowered to do that. They were reporting back to the managers. You don't ultimately need always experts to take care of those components. You can also have more junior people taking ownership. Now, that's obviously has to then filter in that you need the resources from the managers, from more senior folks, to actually provide the support and also have the understanding to look at the output of the integrated components. Now, here's some of the security scanners that are available across the space. So there are more available, but these are some of the core ones in terms of compliance scans, such as NSA, CAS scans, infrastructure, misconfiguration scans, vulnerability scans, SBOMs, generation. There are lots of tools also to create attestations for SBOMs and other resources. Then in-cluster scans as well. If you're running Kubernetes, you want to make sure you're also choosing a tool that can perform in-cluster scans. Now, we're going to focus in the next demo on vulnerability and misconfiguration scanning with Trivy, just because Trivy is the one that I know best. Here's some of the features of Trivy. You can scan Git repositories, file systems, such as any file system, if you're developing a Go application or REST application, it can scan that for vulnerability and misconfiguration issues as well. container image scanning, Docker file scanning, infrastructure as code scanning, Kubernetes manifest scanning, whether that's a Helm chart or Kubernetes YAML manifest, SBOM generation, in-cluster scanning, and lots more. We just added AWS scanning, so you can scan any services that are running that are spun up in your AWS account directly through Trivy as well. Now we are gonna focus on in-cluster scanning, and we're gonna focus on that with the Trivy operator. So if this is our Kubernetes cluster, what is an operator? What does it do? An operator is installed like any other resource within your Kubernetes cluster. Generally, an operator uses a controller of sorts under the hood. Kubernetes runs on controllers, which is basically control loops that check one thing on a continuous basis. And a lot of it is, for example, within GitOps. If you're familiar with GitOps, if not, then don't worry about the term GitOps. But ultimately, controllers check, for example, the actual state, what's running within your cluster, with the desired state, with what you want to have run in your cluster. And the desired state might be defined in GitOps in Git. And then it will compare both states and perform tasks on those comparisons. And an operator does very similar tasks. It has a similar function. It has a task that it's supposed to run on a continuous basis, and it has to make sure that it's performing that task. Like, it's scanning your cluster. Is the task performed? Yes or no? Does it have to perform the task? Yes or no? And then it's going to go ahead and do that. Now, in this case, here's just an overview of a cluster. So let's assume you have an application namespace with your application running, with all of the resources related to your application running. Then you have your monitoring namespace. You have a security namespace. In a security namespace, in this case, we have the Trivy operator running. So you have all of those different namespaces within here with those different components deployed. Now, obviously, it's great if we have all of those components within a cluster, but ultimately you also want to integrate at some point eventually Prometheus, for example, with external alerting tools. For example, right? Now, we are going to focus really what's happening within our cluster, but there's no reason you can't integrate with other external tools. Now, here's the demo time, finally. So, I have here my Kubernetes cluster, and I'm already looking at the vulnerability reports. Now, we head over to namespaces. This is my cluster. I'm looking at it at K9S because it's an amazing tool. So, I have my application namespace with my just app deployment running here. I can show you my app deployment as well in here in my browser. So this is my app deployment running here, just showing some demo applications. That's just a basic demo app, right? It will come handy in a second of why I'm showing you that. Now we want to install Trivy. Here's the Trivy repository with the documentation, everything for the CLI. Now we're going to focus on the Trivy operator, which is kind of a sub-deployment component of Trivy. It has its own documentation. Within the Trivy operator documentation, you can find several different installation options, including Helm. Helm is really amazing because you can utilize the manifest, the Kubernetes manifest that somebody else defined, but you can use basically Helm templating of sorts to make changes to it, which is very, very great. Let me just check that everything is recording properly. Okay. So once we have that, we go back to our namespaces, and here I want to show you Trivy operator running. This is the Trivy operator. It has a service as well, and I'm going to show you the service also in a second. So this is that. Then I have my monitoring namespace with the kubeprometheus stack Helm chart running. And the kubeprometheus stack Helm chart is really amazing because it's deploying Prometheus and Grafana at the same time, which makes it super handy for demos like that. You can deploy one Helm chart with all of your different components that you need. And lastly, I have my Argo CD namespace with all my Argo CD components. Now, Argo CD is really just used in this case to make my deployments happen. So this is my Argo CD. This is my Argo CD interface, my application running here of just port forwarding through localhost, and ultimately have here my app running, and it's just syncing it up. Then the CRDs for Prometheus, and in Prometheus, and here the Trivy operator. Now the Trivy operator is also just syncing. Once you head over to the different components, you can see the different resources that are basically installed, like lots of custom resource definitions. And CODs are basically expanding on the Kubernetes API with custom resources. It's really amazing. Now, Argo CD is visualizing all of that, which is pretty cool. I have all of this running and deployed through Argo CD. As you can see, periodically it's trying to resync it. Now, some of the CODs can't be synced. That's why it's appearing out of sync. Don't worry about that. Okay, so we want to first have our application scan for vulnerabilities. And this is done through the Trivia operator. Now, this is just here the repository. This is ultimately how I installed, for example, the application. The Trivia operator. That's how I installed the Trivia operator. Here I define the Helm chart registry, the target version of the Helm chart, and I can specify any values that I want to change. For instance, I want to integrate the Trivia operator directly with Prometheus, send metrics directly to Prometheus, so I need to have a service monitor running for the Trivia operator, and I'm just specifying that when it performs the vulnerability scans, it should ignore any unfixed vulnerabilities. I only want to see vulnerabilities that already have a fix available that I have to pay attention to. And this is these are filters that help you navigate the noise, right? The toil that I talked about earlier in my slides. That if you define Trivia, like with Trivia, the different components of like the information that you want to gain over other information, that will help you to reduce a lot of the noise. Now, going back to our cluster, right? I have here Trivia system running, and the operator is responsible to perform vulnerability scans on any new container image that's visible within my cluster, and then save it within vulnerability reports. Is it going to show it? No. Let's try this again. Vulnerability reports. Now, there's none in the Trivia system namespace because Trivia is ultimately right now not scanning itself. I told it not to. And here I have my application vulnerability report. And a tool like K9S shows you, for example, in the case of vulnerability reports, all of your like a summary table of all your vulnerabilities, which is really nice. But ultimately, most people shouldn't have access to your Kubernetes cluster. It's really bad practice for me to just play around in the cluster itself, right? It's not a playground, if it's a production cluster especially. So you want to get those metrics out of the cluster. And this is done by accessing the metrics. So ultimately I have here my entire metrics, all of my different metrics, right? And then scrolling down, or scrolling up actually, I can see here my different vulnerabilities, right? Like my different vulnerability reports for my different images, for example, for Prometheus. Or let's go to the next one. I have here of my application a critical vulnerability within my app deployment. Now the thing is, people wouldn't look at the metrics endpoint, right? You wouldn't filter necessarily through the metrics endpoint and through all the metrics that are collected from something like the Trivia operator or anything really that's sending metrics, because there could be a lot of different metrics. So you want to filter through them and display them in a nice, visually pleasing way. And also, if you have access to your, for example, to any metrics or to your security metrics in that case, through tools such as Prometheus and Grafana, you can set up alerting as well. So I have Grafana over here with my different dashboards, and I've added one dashboard for Trivia, the Trivia dashboard, and I have here all of the vulnerabilities within my app namespace, and then all of the vulnerabilities across my cluster. So this is one way how I could visualize my vulnerabilities, also see the health of the different resources within my cluster over time. So for instance, looking at my different vulnerability reports, I have 8 vulnerabilities listed here. 1 critical, 4 high, 1 medium, 2 unknown. Now these are all vulnerabilities that already have a fix available, meaning I could do something about them. So if I get here a new vulnerability within my app namespace, I should get, for example, a notification of like, hey, there's a new vulnerability. Or if it's a critical vulnerability, I should get an alert, right? Now, similar, if here the number of vulnerabilities goes up, I want to be able to address that, right? Now, this is just like visualizing the security health of our application, of our deployments, of our running workloads. But with that, you can set up anything that you also set up for your other SRE-related metrics that you're tracking. There's so much that you can do just with this information by having access to security metrics from your cluster, from your workloads. Now, this is really just everything that I wanted to show. I have a link to the Git repository that has all of those resources. Just check out my GitHub account, Anais Urlichs, first name and a last name, and you will find all of the different deployments, also for Prometheus, and this repository is also Teleport that I'm sometimes using, and then Helm chart, but these are the main ones, and then the dashboard as well for Trivi. Now, this is really all I want to show you. Here's another example from another demo I did where I had more like cluster-wide vulnerabilities, and then also vulnerabilities that were specific for one namespace. And then also, look, like this cluster had like several high vulnerabilities, several medium vulnerabilities. No critical vulnerabilities displayed here, but as you can see, there's a lot that you can do to refine that. Now, here are some of the takeaways that I want to leave you with at the end of this presentation. First of all, SRE goals are security goals. There's a very strong overlap, like we've seen. Security is for everyone. If I can get started with security, so can you, so can everybody. It's not an exclusive club. Just find ways on how you can get started. And security can be Kubernetes native through integrating it with our existing cloud native tooling. There is really a way. Now, thank you so much for watching this presentation, for listening. Please do try out Trivi. Maybe give us a star on GitHub. We would love to hear your feedback, your thoughts. If Trivi is helpful for you, it's all open source again. Like, there's no sign up, nothing required. I hope you have an amazing remaining conference, and to see you around. Have an amazing day. Bye bye.